Okay, so here is our portfolio optimization challenge. So your aim is to try and complete this challenge within 1 minute. So just to outline the problem first of all, you can see there are 5 projects. We can see the cost for each project, and we can see the value, net present value for each project. Down at the bottom, you can see the total cost of doing all 5 is 1,200, but the budget is 1,000. Total value at the moment is 2,000. So you don't have enough money to do all of the projects. You need to cut one or more projects from your portfolio. The question is, which projects do you cut, which do you approve, in order to maximize value, but making sure that your total cost is within budget. So if you're watching this video, you can pause now, set yourself a minute, and see if you can find the right answer. Okay, so otherwise we now carry on with how to do this in the demonstration. So we've got exactly the same data here now inside of Excel. We've also got this additional column. A 1 representing the portfolio is, the project is in the portfolio. If I change that to a 0, we can see that project drops out. So we've got 100 less for the cost and 200 less for the value of the portfolio. We'd still be above budget. Knocking out a second, you can see the total cost is now certainly within the budget, but the value is obviously dropped to be a lot less. With Crystal Ball, we can use the optimization capability to say, I want to maximize my total value, but I've got a constraint that my cost must be within budget. B7 must be less than or equal to B8. B7 less than B8. Otherwise, I go ahead and just run. It tests all the different combinations of portfolios, which projects are in or out of the portfolio. And we can see the increase in value as it goes through the different simulations. So we can see the 1500 that we were starting out on, it managed to increase up to 1700 as it tested the different portfolios, all in about a second. So we can see confirmation of the best solution it found in the bottom half of the window, that the best value it did find was 1700, that our cost is within budget, it's exactly on the budget, and the decision. So they're all 1s except for project 2. So well done if you got that correct and said project 2. Give yourself a pat on the back. How about then if we make this a little bit more complex? What if instead of only having 1 project, we have 10? And what about instead of just cost as a constraint, we also have resource? Maybe this is man days, high level estimate for man days for each project. We've again got a budget or a capacity, if you like, for man days. We've got what is the amount required given the selections that you have at the moment, and obviously similar problem to before. How do we make sure that we get this cost within budget? How do we get the resource also within its capacity? Value, if I just turn them off in the order they are here, drops to 2,100. Can we do better? Feel free again to pause and have a go. Maximize value, cost must be within budget, and we must keep within the available resource. So D12 must also be less than or equal to D13, and then otherwise again we just run. So you can see in Excel how Crystal Ball is simply trying combinations over and over again. Just got conditional formatting in Excel there that allows you to see a little clearer what's going on. And then otherwise, we can see the improvements as it's testing out the different portfolios. And I think it's already pretty quickly converged on the best solution. After 20 seconds, it's tried every combination. And we can see the value it achieved went from 2,100 up to 3,000. Cost of 1,900 is a little bit less than budget. We're right on our capacity. And we can see the combination of 1s and 0s again, either in here, or we also have those populated back into Excel. So project 2 is again out. 7, 8, and 9 are also out in this case. So hopefully that gives you a quick feel for how you can use Crystal Ball for portfolio optimization. Please also feel free to take a look at our other videos for how you can expand this a little by also introducing uncertainty around things like cost. Rather than assuming you have the exact value of 200, what if you capture the uncertainty around that number? And also how you can extend this to also look at things like efficient frontier analysis. Okay, thanks. Bye-bye.